In the last clip, we succeeded in making the first order diagram, and now we will construct the second order diagram. Uh, and what we're going to do first see is the second order diagram, remember, is always made from mixing the first order diagram mixed orbitals. So we have this orbital here. I'll give them new names. This is going to be my phi 1. And which orbital should it mix with? And the most bonding orbital that we can make, we know is, here's what I'm going to do. I'm going to erase the stuff on this side. Really all we need are the center orbitals. And the most bonding orbital we can imagine is this orbital here. This has the most constructive interference. So in blue, there's my phi 1, and my phi 2 will be, therefore, this orbital right here, phi 2. These are the two energies. I'm about to make a bond, so that's going to bring them further apart in energy. The lower energy one will go down in energy, 2 to 4 EVs, and the upper one will go up, 2 to 4 EVs in energy. And this will be psi 1. So I draw it here. This will be psi 2. Psi 2 is the subtraction. So I keep my phi 1 this way. And I subtract my phi 2. And notice that I'm making the hydrogens very big, because this orbital is mainly located on the hydrogens, while this orbital here is mainly located on the oxygen. The lower energy orbital, this is the lower energy orbital, looks more like the original low energy orbital. The high energy orbital looks more like the original high energy orbital, which is to say it is mainly on the hydrogens. Okay, that's one pair of mixing, so mix these two orbitals. Which two should we mix next? I'll give you some choices. Here's A. This one I've already done. B, C, and D. Pick two letters that if you mix them will make hydrogen-oxygen bonds. Pick two letters. I'll give you some time. Put it in chat. Which two letters do you want to mix? And put your answers down. It's going to be A and B. So I'll call this one phi 1. And I'll call B A phi 2. Those are the two I'm mixing. And now put in chat, is the bonding combination psi 1 or psi 2? Look very closely at my pictures of A, which is up here. Oops, I just lost an orbital, so I have to put it back in. Look at that A orbital, the phi 2, and compare it to the B orbital, phi 1. Put in chat, the bonding orbital is psi 1 or psi 2? Put it in chat. I'll wait. The answer is, it is psi 2, because here I'll use when I make a psi 2 here, I take this guy. They're quite close in energy, so they'll be equal size. And I subtract the phi 2. That's what puts them in phase. And the out of phase combination will be then phi 1, which will be this guy, plus this guy. That makes them destructive interference. So now we have in fact used up, this orbital has been used up, this one has been used up, both hydrogen orbitals have been used up. And so the only two remaining orbitals are these two here, C and D. They are both on oxygen. They can't make bonds. We just carry them over. And so we carry them over. We end up with these two orbitals here. And I'm carrying them over at the same energy. We have a bonding orbital here, followed by another bonding orbital. Then we have a non-bonding orbital, which is an sp hybrid, followed by another non-bonding orbital, and then we have two anti-bonding orbitals up here. There are 8 electrons in the system. This is the final, this is the second order, and this is the actual orbital diagram. These are the actual MOs.